Today we're going to talk about inequality in two triangles, and this involves both the Hinge theorem and the converse of the Hinge theorem. So the Hinge theorem says that if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. So what that means is since these two sides are congruent and these two sides are congruent, then since this angle is larger than this angle, this side is larger than this side, which is why it says RT is greater than AC. Now the converse of the Hinge theorem helps us find whether the angle is bigger or less than another angle, whereas the Hinge theorem itself was talking about the sides. So for the converse, if two sides of a triangle are congruent to two sides of another triangle, and the third side in the first is longer than the third side in the second, then the included angle in the first triangle is greater than the included angle in the second triangle. So what this is saying is since these two sides are congruent and these two sides are congruent, we can look at these side lengths. Well, 36 is greater than 33, so angle M, which is opposite that, is going to be greater than angle R, which is opposite that 33. So using the Hinge theorem and the converse of the Hinge theorem, we can solve these 6 problems. So the first one says to compare MR and RP. Well, we have these two sides are congruent, and by the reflexive property, this side is congruent, so we can look at the angles. Well, 21 is bigger than 19, so MR must be bigger than RP. So we would say MR is greater than RP. Now we can look at number 2. We're wanting to compare AD, which is this line, and CD, which is this line. Well, these two sides are congruent. By the reflexive property, this is congruent, so we can look at the angles. 22 degrees is less than 38 degrees, so CD is going to be less than AD. Or we could say that the opposite way. We can say AD is going to be greater than CD. Both will work. Both are correct. Number 3, we're now using the converse of the Hinge theorem because we're trying to compare the two angles. So 24 and 24, so these two sides are congruent. 30 and 30, so these two sides are congruent. Now we can look at the third side to determine the included angle. Well, 48 is less than 50, so the measure of angle C is going to be less than the measure of angle Z. Number 4, we're using the converse of the Hinge theorem again. So we want to know about the measure of angle XYW and the measure of angle WYZ. Well, these two sides are congruent, and by the reflexive property, this side is congruent, so we can look at the side lengths. 28 is less than 42, so the measure of angle XYW is going to be less than the measure of angle WYZ. Now for these last two, we're writing an inequality to find the range for the values of x. So we're going to set up the inequalities like we did up here, but then we're going to be actually solving for x. So for number 5, x is in these two side lengths. Well, we know that these sides are congruent, and we know this side is congruent to itself by the reflexive property. So we can look at the angles to determine what we know about the side lengths. Well, 120 degrees is greater than 115 degrees, so that means 4x minus 10 must be greater than 40. And that's by the Hinge theorem. So we can go ahead and solve for x. So the first thing we need to do is add 10 to both sides. So we'll have 4x is greater than 50. And then we need to divide both sides by 4 to get x by itself. And we'll have that x is greater than 12.5. So that's our range for the possible values of x. We're going to do the same thing for number 6. Except this time x is in the angle measure, so we're going to use the converse of the Hinge theorem. Well, 60 and 60, so these two sides are the same. And by the reflexive property, this side is congruent to itself. So now we can look at the other two side lengths to determine what we know about the angles. Well, 36 is greater than 30, so 33 is greater than 3x minus 3. So 33 is greater than 3x minus 3. And we're just going to solve for x. Add 3 to both sides. We'll get 36 is greater than 3x. Divide by 3 on both sides to get x by itself. And we'll get that 12 is greater than x. And there's our range for the values of x. Now we can go ahead and glue this in to the next page of our books. I guess we need to fold it in half first. So we can glue it in, and then you can title it Inequality in Two Triangles or Hinge Theorem, whatever you want to do. I'm going to go ahead and put Hinge Theorem since inequality of two triangles is already right here. So that way, if I have an assignment that talks about the Hinge Theorem, I know to turn to these notes.